It's fine.
Alright, so for the first 7 problems are factor each expression.
Okay.
And then the first one is x2 plus 22x plus 4.
X squared plus 22x plus 4?
40, sorry.
Oh, good, because I didn't know how to factor it with a 4. All right, so let's go through our steps here. Let's do these one step at a time. Goes here?
Hold on. 22x.
X and X. In other words, the first step is to make sure that this times that is equal to that.
Okay.
Okay, that's always the first step, is to make sure these two terms multiply together to give you that term there. What's the second step of factoring? At least by my method.
Is that to get like the x on one side?
Well, no. The second step is to determine what the signs are going to be. What are the signs going to be in each of my linear factors here?
Positive?
Yes, both of them are going to be plus. And the reason I know is I look at that plus. That plus tells me they both have to be the same. They don't have to both be plus, but they have to be the same. And then I look to that plus, and that tells me they both have to be plus. So that's step 2. And don't forget step 2. Everybody fails on my method because they want to skip over step 2. So now that I got step 2 done, step 3 is factors of 40 that do what?
That add up to 22.
That add, because of that plus sign right there, to just the number 22. Don't try to make them add to plus 22 or minus 22. Just make them add to that coefficient. So what factors might that be? Let's start listing factors of 40. That doesn't add to 22.
2 and 20, 4 and 10.
Ah, okay. We have our answer.
Oh yeah, 20 and 2.
And those 3 steps, if you can remember them, they work every time you have an x squared only. They work very nicely. Gets a little more difficult if you put something like a 2x squared there. But whenever the coefficient of the x squared is 1, this method works great. What else you got?
One sec, let me just write that down.
What I'd like to see you do, Tucker, is memorize the method.
Yeah, that's right.
Instead of just trying to come up with the solution, let's memorize the method, and you will begin to see that, wow, the method is the same every time. If I can just remember the 3 steps or the 4 steps, then you can factor anything.
Alright, so the next one is x2 minus 5x minus 14.
Okay, first of all, let's talk about how we verbalize that. That's x squared.
Oh, okay.
Not x2. If that's what x2 would be. 2 times x. So when you're dealing with an exponent, in other words, that's x cubed. Or you could say x to the 3rd power, or x to the 2nd power. Okay? All right, so what's step 1?
To find that it's going to be x.
Well, step 1 is to figure out what goes here and what goes there.
Right, so it's x, right?
X and x, yeah. Okay, what next? What's
Then to
step
figure
2?
out, um,
Figuring out the signs based on that right there.
so it has to be negative, but they don't both have to be.
Well, in fact, they can't both be. If I had negative times negative, I would end up with a positive in front of that number. Remember that this number comes from multiplying this number times this number. So you can't have, what this minus sign tells you is that the signs have to be opposite. That's all.
Alright, so it's x minus 2 and then x positive 2, correct?
No. The third step, we've done the first 2 steps. The third step are factors of 14 that do what?
That add up to negative 5.
Not add. That's a negative sign. That means they have to subtract 5, not negative 5. The factors of 14 have to subtract to 5. What factors of 14 subtract to the number 5?
7 and 2.
Okay, there's our factors. Now, the fourth and final step here is to put the larger of the factors, that's 7, with the sign of the middle term, that's negative. There's your answer.
Alright.
Okay. What else you got?
X squared plus 2x minus 63.
Go through all 4 steps for me.
Alright,
Goes here and here.
x plus and then x minus.
Okay. I prefer step 1. I mean, maybe I'm being a little picky about this, but that's step 1.
Alright, yeah.
Because when you run into that, then step 1 is going to be 2x and x. In other words, step 1 is spelling out what goes there and what goes there.
Okay.
Okay? So it's x and x. Now, step 2.
To figure out, also, the first one's a positive and the second one's negative.
Figure out the signs. That's step 2. Signs have to be opposite because of that. And it could be positive or negative or positive, but in this case, either of those is the same. There's no real difference. So I can just say positive and negative. What's step 3?
To figure out what more factors of 63 add up to 2.
Not add, not add. Why is it subtract?
Because
that negative sign in front of the 63.
Right.
So factors of 63 that subtract to the number 2.
9 and negative 7.
9 and 7. Where does the bigger factor go and why?
First one because it's positive, so for it to subtract, that's how it has to go.
Because the middle term is positive. And that's the thing that determines where the bigger factor goes, is the sign on the middle term. Okay? These all get to be real easy once you get those 4 steps down. By easy, I mean anything that starts with an x squared.
Yeah. Here, so the next one I have is 9x squared
Okay. These get harder. What else?
minus 49.
Well, that's not hard because what's that thing called? In other words, this is not what I call a hard quadratic to factor because it doesn't have an x term in it. These are easy to factor. If you can remember the name of this, it's called, I'll give you a hint, starts out DIF. There you go. Difference of perfect squares.
Okay.
Or just the difference of squares. Usually, about your grade, they drop the perfect. It doesn't really have to be perfect. We can treat anything as the difference of squares. But notice what we're looking at. We're looking at, that's a perfect square. That's 3x times 3x. That's a perfect square, 7 times 7. And it's the difference because of that.
All right.
So remember that name because that'll help in spotting it. Now, what does difference of perfect squares mean? Well, if I have a squared minus b squared, it always factors into a minus b times a plus b. Okay? So in our problem here, what is a and what is b? Notice
A is 9 and B is...
Oh, hold on. Notice that this a right here is the square root of that. This b right here is the square root of that.
Alright, so is it 3 and 7?
Yes, 3x. In other words, a is 3x. Notice that a squared would be 9x squared, which is what we're looking at. B is 7. Therefore, b squared would be 49. So what we have here, and in fact, let me write it like that. We have the quantity 3x squared minus 7 squared. So what is that going to look like after you factored it? It's a minus b. What's a minus b?
-4.
No, what's a minus b? You can't combine variables and numbers. In other words, 3x minus 7 is the answer for what a minus b is.
Alright.
You can't turn that into a minus 4. This is a number. This is a multiplier of a variable. What goes over here? What's a plus b?
3x plus 7.
Yeah, that's the answer. 3x minus 7 times 3x plus 7. Now, notice how I got that. You always, if you're looking at the difference of perfect squares, then a is always the square root of that, and b is always the square root of that. So let me give you another one like that. How would that factor?
So A would be 5, and then B would be...
Not 5. 5 times 5 is not 25x squared.
5x.
Okay. What's B?
6,
It's the square root of 64. That's a perfect square number. That's one you really probably should know. That's 8 squared. 8 times 8 is 64. Okay, so once we've found out what A is and what B is, then what does this thing factor into?
5x minus 8. And 5x plus 8.
Good. All right, now, I think you got it, understanding it. There's one that a lot of people don't see when they first spot it. What's this? Okay, what's A? What's B?
0x minus 1.
Hold on, what's A?
0.
It's x. The square root of x squared is x.
Alright, and then
In other words,
1.
if I take the square root of x squared, that's always x. And then 1, exactly. B is 1. that's what people don't see, is that 1 is a perfect square. So how does x squared minus 1 factor?
X minus 1
Times
x plus 1.
exactly. Now, difference of perfect squares is big. You're going to need to know that for 2 or 3 years. It's in all levels of math. So you really want to learn to spot it. And you spot it by the fact that there's an x squared term and there's a number, and there's never an x. In other words, the moment I write that, it's not difference of perfect squares. The only difference of perfect squares is this thing has to be a perfect square, subtraction sign, another thing has to be a perfect square.
Alright.
Like 9x squared minus 36. How does that factor? I'm going to erase this now. And you may or may not need to do this. You do this 3 or 4 times and you won't have to keep doing it. But it is helpful when you first are getting used to factoring difference of perfect squares to figure out what A is and what B is.
3x and 6.
So how does this factor?
3x minus 6 and then 3x plus 6.
Good. You got it. Let's go on to the next one. In fact, you probably have a few that look very much like that, I would guess.
So these ones are solve each equation by factoring in x2 plus 6x plus 8 equals 0.
Okay. Now, okay, so let's factor that.
Okay, so
First step?
6x.
No. First step. What goes here? What goes here?
Oh, the x.
X there, X there. Okay? You gotta get both of them in there. Second step.
Both will be positives.
Third step. Spell it out to me. I want to make sure you have this methodology memorized.
That has to be two numbers that multiply to 8 and add to 6.
Correct. Add because of that right there.
So it would be 4 and 2.
There you go. And it doesn't matter which one goes where. Okay? So now,
if it's negative?
What's that?
Does it only matter if there's a negative in the problem?
Yes. In other words, if it's opposite signs, then it does matter where the 4 and the 2 go. If it's the same signs, then it doesn't matter.
Okay.
Now, why can we solve this problem by factoring? In other words, how come I couldn't solve the problem when it was like that? There's no way to solve that. The reason we can solve it by factoring is because algebra says that if you have two things multiplied together, in other words, this quantity times that quantity, and it's equal to 0, then I can solve by setting this equal to 0 or this equal to 0, because otherwise you wouldn't be able to get 0. There's no way to multiply two numbers together and get 0 unless one of them is 0. So the very next step when you get to this is to do this. That means x plus 4 equals 0 or x plus 2 equals 0. Well, if x plus 4 equals 0, what does x equal?
0 or 4?
X plus 4 equals 0. How do you solve that equation?
X equals negative 4.
Okay. And what about the second one? If x plus 2 equals 0, what does x equal?
X equals negative 2.
So there's your two solutions to this problem.
Alright.
Okay. So factoring is usually just the first step in solving an equation. What else you got? If you have one that has a coefficient in front of the x squared term, let's do that. In other words, so far we've done nothing but easy ones.
Yeah, I don't. It's a chapter review, so I'm pretty sure we have a review, but we're not going to have any with them.
All right, well, let's keep going on what you have in your review.
All right, so x squared minus 10x plus 25 equals 0.
It's only these that you can use the exact 4 steps that I'm giving you.
Okay.
When you end up with a coefficient in front of the x squared term, none of those 4 steps really apply anymore. I mean, the first 2 do, but okay, so step 1.
Alright, so there are x's.
Step 2.
And then the first one's going to be a positive.
Okay, step 2. Let's review step 2. Step 2 is to examine that sign. The fact that that is a plus means what about these 2 signs?
That they're both going to be,
they're both the same.
Oh, okay.
That's all it means. It doesn't mean they're both plus. It just means they're both the same. They're not plus and minus. They're either minus minus or they're plus plus. How do we tell which one?
Because the negative 10?
Yes. In other words, once you've determined that they're the same, then they're whatever the middle term has. Okay? Now what? What's the third step?
To figure out the numbers, and they are...
Go ahead and state it. Factors of 25.
Factors of 25 that add up to negative 10.
Good. No, that add up to 10. Not negative 10.
Okay.
We've already put our signs in. So the only thing we're really looking for, well, 5 and 5, they add up to 10. They don't really add up to negative 10, but they add up to 10. And that's always the way it ends up being. So what is our solution?
X equals positive 5. And then x equals positive 5 again.
Right. So this is actually called a solution with multiplicity of 2.
Oh, so you just leave it like that?
Yeah. In other words, there's only one solution, x equals 5. But it's multiplicity of 2 because there were actually 2 solutions. They were just the same.
All right.
Okay. That multiplicity, you don't get that until pre-calculus. But okay, what else?
X squared plus 12x plus 32 equals 0.
Okay.
So x plus...
Okay. Don't make the mistake that you are repeatedly making.
Oh, okay. So
which is your step 1 is this. That's not step 1. Step 1 is this. Step 2 is not that. Step 2 is examining that and figuring out that the signs have to be the same, both of them. In other words, step 2 is figuring out both signs, not one at a time, but together. So this tells you what?
That they're going to be the same.
And this tells you?
That they're going to be positive.
Okay, there's step 2. Don't get ahead of it. Now what's step 3?
To figure out 2 factors of 32 that add up to 12.
And what are they?
Hold on.
Let me show you a way of factoring a number that's fairly slick. I know that it's 32 and 1 for sure, right? are factors of 32.
Yeah.
Well, if I have this and double this, I get the next set of factors. And then if I have this and double this, I get another set of factors. So that's kind of an easy way to do numbers like 32. It doesn't always work for all numbers, but for even numbers it works quite nicely. And that's what we're looking for right there. Factors of 32 that add to 12. Doesn't matter which goes where because they're the same sign. And now what's my solution?
A equals negative, or x equals negative 8 and x equals negative 4.
Correct. All right, let's do one more. Actually, I'm kind of glad that we're working with ones that don't have a coefficient because it's giving you a chance to really drill these.
Yeah.
Got another one?
X squared minus 2x minus 15 equals 0.
Okay. I'll try to keep my comments at a minimum.
Alright, so the two, whatever they're called, are going to be x. And then negative 15, so they both have to be negative, correct?
Well, if they were both negative, what would the sign be in front of 15?
Positive.
Okay, it's not positive. So they're not both negative.
So one of them have to be negative?
And one has to be positive. And the way to state that is they have to be opposite signs. The whole step 2 is figuring out what both signs are. And we know that they have to be opposite. Okay? Step 3.
Figure out what factors they are, which they are.
Hold on. State the whole thing.
Figure out what factors of negative 15 add up to negative 2.
No. Not factors of negative 15. Factors of 15 and not add to 2.
Subtract.
Because that's a negative sign. Whatever that sign is what these factors have to do. In other words, they either have, if that's a plus, then factors of 15 that add to the number 2. If that's a minus, then it's got to be factors of 15 that subtract to the number 2. Not the negative 2, but to that number 2. Well, what factors of 15 subtract to the number 2?
5 and 3.
Okay, which one goes where?
5 goes first.
No, the larger factor. We've found our two factors. The larger one goes with the sign of the middle term.
Oh, okay, so it goes with the negative one.
The reason is, notice why. Because that negative term, that middle term is made up of the inside plus the outside. Well, the inside is 3x. The outside is minus 5x when you multiply them, and then when you add these two terms, you get minus 2x. That's our middle term. Okay. So what's our solution?
X equals negative 3 and x equals positive 5.
All right. That's good. We could use a little more time drilling this. I want you to get to a point where these are automatic. Because the moment you put a coefficient in front, now you got to throw out all those 4 steps pretty much and start the whole process differently. But as long as you're starting with an x squared, these all boil down to that simple 3-step process. And if you don't get ahead of yourself and always stay step 1, step 2, step 3, you'll get every one of them right.
All right.
Okay? All right, Tucker. Have a good one. I'll talk to you next time.
Thanks.